Good morning. My name is John Hartley, Chief Commercial Officer at Syntacore. So thank you to the few that have managed to come and do this face-to-face. It's nice to do something that resembles normal, and hello to the folks that are online. So just going to walk you through where we are here at Syntacore, product offering, some news, announcement or two, give you a feel for where we are in terms of our roadmap, new products and development. So just start with a range of RISC-V compatible cores, then the environment in which our customers were developing, some IPs, new IPs, and then a quick summary. So we will take some Q&A at the end. My colleague Alex is down front. Alex is the CEO. Any questions that you have, we'll do our best to answer. So semiconductor IP company. We're a founding member of the RISC-V Foundation, and as of today, we're a premier member. So everything that we do is around RISC-V. We've been involved since the very beginning. What we do is develop and license state-of-the-art RISC-V cores. That's what the company does. That's the entire foundation and purpose of the business. So what we have is available immediately. We have a huge back end of resource to support customers. Many years of combined RISC-V experience, along with many years of working with other architectures. A huge design team working around the clock to keep our customers happy and motivated. SDKs in silicon and full collateral to support. So all the things that you would expect for a professional company. Full service to specialized CPU IP for customers' needs. So we've got one-stop workload-specific customization and improvements, IP hardening in some cases where the customer needs it, SoC integration and software migration support. So we consider the support that we have to be best in class. So in terms of the people that we have in the company, we have around about 100 EE engineers. We're headquartered in Europe, and our R&D and design staff are based in Moscow and St. Petersburg. We also have sales support and developing app support globally. So in Europe, I'm based in Cambridge. We have people in Asia, and we're building out our US infrastructure. So in terms of where we excel, so it's high performance and low power embedded cores and IPs, as you would expect. ASIC technologies, reconfigurable architectures, and compiler technologies. So we're focusing on application class Linux capable multi-cores and CPUs. So we have some samples of where we have moved into production on our booth below in the RISC-V area. So in terms of some of the things that we've done, that we've achieved so far, we've commercially deployed our SoCs up to 5 nanometer. We were the first RISC-V guy in 2016 with a Linux capable IP and full wafers from 2017. So we have multiple different successes from, I think from 130 right down to 5 nanometer on multiple foundries. 5 foundries and working on a couple more. And mass production and tape outs in many more. Up to 50 plus cores, heterogeneous, very complex systems, and an activeless SoC on 22 nanometer. So we're not typically a company that over markets our successes and our achievements. We just very quietly in the background are working hard to keep the customers happy. We are starting to increase our coverage because we now are in a situation where we're ready to push forward and to tell the world where we are. So our customers are global. We have tier 1 customers, we have multinational customers, and typically the way we operate is to give references as opposed to press releases. So anyone who's interested in working with us and want to figure out where we are and how we've supported customers so far, happy to provide references. So this is our current roadmap or our current available IPs. So we have 8 in production, 8 cores, 5 are microcontroller class and 3 are application class, all available in 32 and 64 except the SCR1. Everything is silicon proven, so all ready to go. Most cases are in full production, but MPW at the worst case. And again, we have samples of some of these on our booth B9 below in the RISC-V area. Our newest one is the SCR7. New, I say that it's more than 2 years now that's been out there. We're working on lots of designs. It's in full production. That's our flagship core. There are a few gaps in the roadmap which we're going to address, so we'll talk a little bit later about one area where we're introducing today actually a new core that just complements the existing roadmap. So in terms of what we have, so we start with, I'm not sure how well you can see, it's a bit of an eye chart, there's lots going on there, but we start with the SCR1, which is our first, our freely available to download on GitHub. It's the most downloaded RISC-V core on GitHub. It's very well received. That's comparable with the Cortex M0, M3. That's been openly sourced since 2017. And like I said, it's the most popular RISC-V based core on GitHub that's been downloaded. So that we give that away, that's free. And then we offer support and maintenance to customers should they require it after the fact. Going to the SCR3 and SCR4, so they're just a step function in performance from the SCR1 with some increased features, things like memory subsystems with 2 caches, ECC and partially protected, and support for coherent multi-core configurations, including heterogeneous. Then the SCR5 is a compact Linux compatible core. And that's if you have a small footprint and you're in the Linux space, then the SCR5 is the way to go. And then the SCR7 is our efficient Linux capable mid-range core with some out of order capabilities. So the way that we built the roadmap is pretty much in line with where the industry is and what's required, but we focused heavily on customization. So if somebody needs something in between a 3 and a 4 or a 4 and a 5, then there's a whole suite of customization that we can offer to get the customer where they need to go. So it's more solution-based. It's what problems are you trying to solve? And then we do the best to increase performance to get you where you need to be. So if there's something that you need or you have a requirement for that doesn't quite fit, then the customization that we offer generally gets you where you need to go. So we can also do unique configurations to any of these cores as customers require them. So this is the SCR7, this is the one I mentioned. This would be our flagship core, mid-range application core. So it's octa-core, and it's 2.5 gig at 28 nanometer and less than 2 gig on the smaller nodes, on the 10 nan and below. So we actually have a demo of this, which we're going to show, I believe, tomorrow at 3 o'clock on the RISC-V booth. One of our gentlemen is going to be streaming that. So you can, if you're interested to know more about the SCR7, then you can go find it on the booth, and we're happy to answer any questions that you might have. So we have many, many customers with the SCR7, multiple applications. It ticks all the boxes. It's the one, I guess, that most customers inquire about. This is just some spec comparisons. So we compared the SCR7 with the Cortex A53, and pretty much on every different variable we outperformed. So it's a 20% improvement on the A53. ARM then did a bake-off between the 55 and the 53, and they were 18% better. So for us against the A53 or the A55, the SCR7 has a minimum of 2% improvement on the 55 and up to 20% on the 53. So we feel we're competitive in that space, and we worked hard on it. It's a very well-used core from the Syntacore range, and we're punching above our weight. We have an FPGA-based SDK, so anyone who's interested in looking at or developing with the SCR7, we have a suite of tools to support that. That's available. We can help you figure out how to do that. We have a dev kit and all the things you would imagine you would need to start development. So just a quick summary before we go to any questions. So the key benefits, really, application class Linux, multi-core CPU clusters, and turnkey customization. Customization is a big part of the offering. It's not just a roadmap and a suite of IPs. It's how we customize and tweak them to meet the customer's particular challenges. So again, we're selling based on solutions as opposed to this is what we have, we hope it works. Clean slate, silicon proven, multiple designs, multiple customers in multiple countries, multiple tape outs, lots of customers going into full production, a broad offering of RISC-V in the ecosystem. We only do RISC-V. That's all we do. That's our business. We're not detracted by anything else. Everything that Syntacore does is around developing roadmaps, developing IPs for customers, and supporting the ecosystem. Big team, experienced team, around 100 EE engineers that are on hand to support if needed. Evaluation is easy, licensing is flexible, lots of different ways that we can provide licensing. And, customers are interested in just starting the RISC-V journey. The SCR1 as a free core is a nice way to test the temperature. Obviously, we support that with a support and maintenance contract if required. Development suite, as you would imagine, we need to have stable IDEs in production, which we do. We need to work with all the main ecosystem partners, JTAG-based debug solutions on offer, all the simulators you can possibly need or want to work with, hosting with Linux and Windows, and BM and Linux, as I mentioned. So we work closely with Lauterbach, IAR, Sega, and others in the RISC-V ecosystem. So all the third-party tools and vendors are all clearly part of this ecosystem, part of the RISC-V journey. All that is part and parcel of a deliverable. And in terms of what a customer would get if they make the decision to work with Syntacore, is a somewhat industry standard, but more. We emphasize heavily the after service and collateral. We want to make sure that it's a positive journey, so you come back for more. So all the standard deliverables you would expect around tools and SDKs and software and documentation. We also do on-site support if required, and we also do SoC integration and software porting. They cost a little bit of money. They're going to cost a few dollars over and above the license fee. And we also do hardening if it's something that the customer has a preference to investigate. So all the things that everyone would have, plus a few more. So today we're announcing the STR6, and that was the one that I mentioned earlier. That was the gap in the roadmap. That's now out. We are working with customers on the SCR6. The roadmap is basically driven by where the market is and lead customers. So lead customers have a requirement, they have a need. We would then step up and do the best we can to accommodate. So that's now out, a formal release. It's high performance embedded MCU processor, 1.5 gig at 28 nanometer, 500K gates per core. So it's just, it's not supersonic, it's not the leading edge for us, but it fills the gap in the roadmap, and it's a very well used core in industry. So enough people asked us for it, so we added it to the roadmap today. And then we will be making another announcement. We may have done something here at the RISC-V Summit, but we're now going to do it probably embedded world next year. So we're pre-announcing an IP for release in Q1 22, which is a high-performance IP, which primarily we're likely to be used in entry-level server applications. So it's a beast. It's a big guy, Linux-capable application class, 8 to 16 cores or quad, coherent, a NOC, coherent external, ZTSO hypervisor. So we're pre-announcing that. We're having NDA conversations with customers. We have lead customers who we're working with. Anyone who's interested in understanding more about what the next SCR number is going to be and what that looks like, we're happy to accommodate. But it's a pre-announcement. It's more of a teaser, and that will be coming to fruition in Q1. So SCR1, as I mentioned, is fully available and free on GitHub. You can go and take a look at that. Unrestricted use, and then support and maintenance is something that we cover afterwards. All the other cores is available after evaluation agreements are signed. So we need some kind of commitment from the customer they're going to do something with it, and then we would release a license agreement. And please go on to evaluation at Syntacore for more information. So in a nutshell, high-quality RISC-V compatible CPU IP, that's all we do. We don't do anything else. Premium member of RISC-V, very, very focused into the ecosystem. We understand that there's a challenge to move from one to another or to start the journey. So we're fully embedded into the ecosystem and the RISC-V community, silicon proven, and shipping full wafer production with most of our cores. Turnkey customization, which is a big part of the Syntacore way, the Syntacore story, is the customization. So we emphasize that heavily. Tool and compiler support, as you would imagine. Strong collateral base, lots of other peripherals that we offer that others don't. turnkey, drop-in compatible replacement, including software stack, which is also a big deal, and not everyone offers the software stack support. So customization is the key here. And I think that's it in terms of slides. Did we have any questions from the floor that we can help with? We have one at the back there.
All right, Q&A time. If we have questions online, please make sure you get those into the chat. If there are questions here, just raise your hand and I will take that from you and then repeat it. Go ahead. The question was whether there were any plans to add a vector unit to any of your cores here.
Do you want to take that one, Alex?
So hello, yes, I'm Alex, I'm with Syntacore as well. So yes, we do have vector unit compatible with the recently approved specification. I think review period is done, so if you're interested in details, come to the booth, we'll talk. Thank you.
Okay. Any more questions? I did have one. You mentioned quite a few set of customers. You said you'd provide references. Can you say anything about like solution space or application spaces that of the people that you're working with?
Yeah, so maybe Alex, you can speak at a high level. Obviously, we wouldn't disclose who, but from an application standpoint, maybe we can talk a little bit about these mass production examples.
Yeah, so is the question regarding entire product line on some specific cores? Entire product line?
So what space are you?
Okay, so basically across the board. So we have storage, communications, generic embedded, then different types of accelerators, including on the high-end side. We have high-performance applications. Let me think. Communications I mentioned. Yeah, probably that covers a majority of use cases.
Anyone else? If not, then let's give John and Alex a round of applause and thank them for their time.
Thank you very much.